All right, so in this video, we're going to be looking at solutions for quadratic inequalities. Now, the main idea here is that just like when we're solving quadratic equations, we want everything on one side of the equation, so the other side is equal to 0. That's going to make our lives so much easier because we can rely on factoring and sign changes. So in this particular example, everything is already on the left side of the equation and 0 is already on the other. So we can proceed with factoring to get our points where the sign of the graph is going to change, where we're going to cross over from negative to positive or positive to negative and thus go through 0. Now, in this case, we're going to end up with x plus 3 and x minus 1 and are equal to 0. And again, you can see that 3 times negative 1 is going to give you negative 3, but 3x minus 1x is going to give you plus 2x. So our 0 points on our graph are going to be negative 3 and 1. So one way that we can go about thinking about this is to draw a number line and then plot out our sign changes on the number line. So here's our number line. We have negative 3 is one solution and 1 is the other. Now we want to think about the sign of our graph, because if it's positive, it's going to be bigger than 0. And if it's negative, it's going to be smaller than 0. Now, we can think about this graphically because this is an opening up, a parabola that opens upward. And so it's going to have to be V-shaped or U-shaped, which probably means this will be positive, this will be negative, and this will be positive. But we can put in values to double check. So let's say I put in the value of 0. If I put in the value of 0, I can see that in my original equation, I'm going to get negative 3. Again, ignore the inequality for a moment. This side of the equation is going to be negative 3. I can also see that if I put 0 into here, I'm going to have 3 times negative 1 is going to be negative 3. So that means that this region of the graph is going to be negative. If I put in a number which is less than negative 3, so for example, negative 4, it's a little harder to evaluate up here if it's not 0. So I'm going to put it in the factored form. Negative 4 plus 3 is negative 1. Negative 4 minus 1 is negative 5. A negative times a negative is a positive, so that's going to go over here. And if I put in a number bigger than 1, like say 2, I'm going to get 2 plus 3 is 5. 2 minus 1 is 1. Positive times a positive is a positive. Again, I don't particularly care about the value. I care about the sign because it's the sign that matters for my solution. So this is telling me that the graph is positive and therefore greater than 0 when I have values that are less than negative 3 and greater than positive 1. So now I can write my solution to my inequality, negative infinity, comma, negative 3. And because it's a greater than or equals to, I will use a square bracket, union, square bracket, 1, because 1 is included, because when it's 0, it satisfies the inequality, and then infinity on the other side. If this was strictly greater than 0, then I would use round parentheses on both ends. Great, so let's look at another example. 3x squared less than or equal to 11x plus 4. So in this case, I want to first put everything on one side of the equation. And then I want to try to factor it if possible. 3x and x. I'm going to, in order to get to 11, I'm going to need 3 to multiply by 4. So 4 is going to go over there. I need 11 to be negative. So that'll give me negative 12 and then plus 1. And then just double check. That's negative 12x. This is plus 1x. It gives me negative 11x. And 1 and negative 4 gives me negative 4. Okay, that's good. Those are my factors. And so now I can, again, draw my number line. Be straighter. There we go. The value that I get for my first fraction is going to be negative 1/3. And the value I get for my second factor is going to be 4. Now, again, what I want to do is I want to think about what signs these are going to be. So again, I can think of this from the visualization standpoint. This is an upward facing parabola. Therefore, it should be positive, negative, positive, but I can double check by plugging in values. So if I plug in, let's say 0, I'm going to get negative 4. And 0 is between my two numbers. If I plug in 5, I'm going to get something positive here, and 5 minus 4 is also going to be positive. Positive times positive is positive. If I plug in something like negative 1, I'm going to get 3. Negative 3 minus plus 1 is going to be negative. Negative 1 minus 4 is also going to be negative. Negative times negative is positive. So this is, again, what I was expecting. But this is less than or equal to. So I need to be in between or possibly including these values. So negative 1/3, comma 4. Now let's do one last example that's a little bit of a special case. Now in this problem, again, we're going to have to move everything over to one side of the equation, and that's going to get us minus 6x plus 9 is less than 0. And in this example, this is going to factor as x minus 3 squared. So there is only one place where this is going to change sign, not two. Boy. And that is at 3. Now, again, upward facing parabola. So this means, again, I can check values. If I put in 0, I'm going to get negative 3 quantity squared is going to be positive. And if I put in anything bigger than 3, like 4, I'm going to get 4 minus 3 is 1. 1 squared is positive. So this is also positive. Now, in this particular case, it's never less than 0. It's exactly 0 at 3. You can say the empty set. It's exactly 0 at 3, but it's never less than 0. If this was this problem, but with a greater than sign, then it would be everywhere except 3, because 3 would be 0, and without the equality, then I would have to remove that from the domain. So then it would be negative infinity to 3, union 3 to infinity, if the inequality was greater than 0. But here, it's never true, and there is no solution. And again, that can happen, and you'll sometimes see that happen also when you have not just these perfect squares, but even when you have the equal sign, then it can happen if you have, for instance, a complex root, like x squared plus 1, that's never going to be negative, for instance. It's never even going to be 0. So there's going to be times where, yes, you're going to get the empty set as the solution.